Okay, what's up, guys? So I'm like full-fledged sick today. Yeah, it happened. It got me. I'm sick. I had to call in again today. I felt like ass. Couldn't sleep, so I was waking up feeling like ass last night. So, late start to my day. Total bummer. Getting sick is not fun. Let's see. There we go. Devlog start session. Fix. It's 3:27. Starting at technically 1 o'clock. Okay. And I do not feel very great. Even now, I took a lot of medicine, but it just isn't working. Like, it just doesn't really fix it. Anyway, we are getting closer, very close to having comment, I guess we'd call it restructure review comments for the dir check function, which pretty much encompasses the entire data transfer modification. I mean, it's like 75% of it as far as lines go. So we're almost done with that. I think we stopped here. I will get rid of this line. Okay. And now I actually need to review the comments because the comments are going to be out of whack. Let's see, inside of dir check. To do line by line review of comments after is finished. Okay. And let's not forget about checking our link, so let's pause it. Still think the volume's a little, lower the volume a little bit on that music. Okay, yeah, so that's good. Link is there. Let's paste it and then delete it, post it, and exit out of this one, and then let's verify that it works. Okay, and that's good. Alright, so now we are back to it. So let's look at this section. If item is equal to skeleton clickable card list, or item is equal to skeleton clickable card list. Okay, this is for receive. So here's the deal. I am pretty sure I'm gonna have to do something that I didn't want to do, meaning that I'm gonna have to restructure these various entries in VirCheck. It's really not that big of a deal, but currently we would grab the entire skeleton clickable card list. But I think, you know, to be more precise and to directly to reflect the exact order of operations that are done on the server side, which is obviously what we want. This means we would need to, instead of checking for any changes to the clickable card list, we would, well, so okay, like on the one hand, yeah, we wanted to handle each individual card on a timestamp basis and not just look at the entire clickable card list. But I think practically, when we deal with the skeleton clickable card list, like all of the changes will be happening at one time, and by that I mean whenever we like since the game is not like an MMO, the game doesn't have the problem of like two players operating at the same time. It's more like turn-based, to where whenever we enter into a section of the skeleton card list, or a part of the game that modifies the clickable card list, despite the fact that it's going to be modifying multiple cards at one time, I don't think that there's going to be I don't think that there's going to be any data that would be altered in between the alteration of this clickable card list. And by that I mean we could probably leave it as it is, since I don't think we would have to worry about, like, let's say halfway through modifying the skeleton clickable card list, we like change the player's name or something. That doesn't really happen in this game. So although it would be more like technically precise to check the timestamp for each card, I think that practically speaking, we could probably leave this as it is. And that makes me wonder about the decision I made yesterday concerning the restructuring of this section, which, well, multiple sections for the card group data dict, the skeleton deck dict, and the skeleton player data dictionary. I see, this is just one of those things where hindsight is 20/20, and it's just strange, you know. I guess you can call it learning, whatever, but now it seems obvious to me that, and I might be wrong here. I might, I am sick and I have like brain fog, but I think that, um, practically speaking, these skeleton lists and stuff would be perfectly fine left as is, instead of handling them on a precise timestamp basis. But okay, hold on. So let me think this through, because this is actually really important. This is like one of the main parts of this is one of the core components of the game. So we have the what do you call it? So everything is gonna originate. I'm sorry, I'm really sick, so I'm just I'm out of it. But I don't want to just sit here and do nothing, so I'm gonna work. If we have the server side, so we're gonna start from the server side, and we just started playing the game. So let's say it's player one's first turn, and they choose to make a play. So let's propose that the player draws a card from the hand, and then the player goes to play all of their cards. So if the card being appended to their hand was sent in the same, along with the same object as the addition of all of their cards from their hand to be transferred over to pre-sort play cards, then on the receiving end, after we transfer that over the network, if we didn't use a precise timestamp system, there would actually be no way for the game to know which card should be moved first. You see what I'm saying? Like, it would, like, if the receiving end wasn't organized in such a way as to just like make the hand card get dealt first or whatever, it wouldn't know that that card should be handled first. It might handle one of the play cards first, and then it would be like out of order. You see what I'm saying? So going through that like mental exercise in my mind, I think that probably necessary, because there's a lot of odd behavior, you could say, that I wouldn't expect from the data transfer system, where like you would think that because it's so fast that those two operations wouldn't have a chance to be confused with one another, like they would be completely two separate send packets or whatever you want to call it. But I'm pretty sure that stuff like that does actually happen in the game, and that it causes lots of these visual bugs that we've dealt with for like the past few months. Um, so in light of that and thinking that through, I actually, I hate to say this because you know it's a system that's already in place. I would like to keep it as it is, but I think honestly, if I wanted to do it the right way, like the truly correct way, that would eliminate all possibilities of visual bugs like that, and we want everything, and we would have everything happen on the receiving end exactly as it occurs on the sending end, then we would need to have a timestamp for every single card, every single operation that happens, um, and apply the data based on those individualized timestamps. Which means this group, I mean this section right here for this card group, the skeleton clickable card list, and the ones above that I was just about, I think we would have to restructure the logic at least a little bit. Like we probably would have item equal to the actual card group instead of well, in this case actually the clickable card list is the actual card group, so this one is a little different than the others. Yeah, actually this one, like, okay, so with this actual card group, I think we could honestly leave this as is, because this is an individual card group, and since on the originating side, or you call it the server side, would be appending the clickable card list in a particular order, that means, well, I never really thought about this, that means we would be, no, I was thinking we would have to apply in reverse order, but that's not true. Yeah, we would want to apply from the beginning of the list to the end, or appending from the beginning to the end. Yeah, so actually this is probably would be okay, meaning like we wouldn't actually have to reference the individualized timestamps for each card. Because this can get really ugly actually if like the individualized thing can also be problematic. That's why I would prefer to individualize as little as I actually have to. Just because it's a lot more like, it's so many more instances of data transfer, as opposed to when we handle it as a group like this, it's, you know, it's one instance. But okay, so let's say we were transferring the clickable card list, let me rephrase that. Let's say we're modifying the clickable card list on the server side. Let's say we're appending, you know, the 13 cards that are in the player's hand to the clickable card list. And as long as those cards are appended in a particular order, which of course they would be, the first card would be appended first, and so on and so forth. That would be perfectly in order, so that by the time we sent it and it was received on the client side, once the clickable card list was received and we entered into this section here in DirtCheck, I think that it would apply the data correctly no matter what. Like, because it's gonna be in order by virtue of the fact that it is a singular operation, a singular ordered operation from the originating side. Now, when you speaking of all of the data that's been changed on the server side per packet, that is not an ordered thing, because, well, some things are changed first during one packet, and then during another section of the game you might change the discard pile first. You know, it all changes. So for it to be ordered, it has to be ordered not completely individually, like not based on every single card in particular, but it has to be ordered up until the point to where it is already ordered from the receiving side. So in this instance, I think clickable card list and skeleton click cards list would already be ordered. Now, I've been like talking through this to try to ensure that by thinking about the different instances where we use it, and I could just review, but I know that I've played it enough, I've worked with the code enough, I know that we handle the card list in such a way that but then here's another question. So let's say that we have considering the 4-second delay, let's say that we have half the clickable card list gets sent in one packet, and then the other half of the card list gets sent in a next packet. I was thinking, well, does that mean that you wouldn't be able to use the other half of the clickable card list for another 4 seconds? But that's not true, because you know, it would probably just be like 0.3 seconds between the first packet sending and the second packet sending, and you wouldn't apply the first section until it had already been 4 seconds. So there wouldn't be a 4-second delay between the application of each half. There would be like a 0.3 second pause between each half. So I think that was all the things I was concerned about. Now, I'm gonna go ahead and just to see, like, we're gonna highlight clickable card list, and we're actually gonna go to progression, which is the game progression functions, how the game starts, and all that stuff. it progresses, how it progresses through the game from the beginning to the end. So we're gonna go over here, and I'm actually gonna copy this. I thought I did, but I tried to do it. Now we're gonna switch back to progression. I'm gonna paste clickable card lists in. So yeah, so looking at this validates my train of thought. I'm pretty sure that this would be fine. Like, there wouldn't be any issue with handling not on a card by card basis, looking at the timestamp of the when that particular card was changed, but rather handling the entire clickable card list as it currently is handled. I think we would be safe. So this is when it gets cleared. It's cleared. The current card. Now let's see it. Yeah, so as you can see, we don't have another thread that's modifying data. This is the thread that modifies the data. So we do have two other threads which receive and send data, but they don't actually modify the data. Meaning we don't have to worry about anything being tangled up. Like an event that should happen in between, in the middle of this list being handled. Let's say the player name got changed or something in the middle of this. That doesn't happen. So whenever we send the clickable card list, we don't have to look at the timestamp of every single card in the clickable card list. We could just say, yeah, the clickable card list was handled all at once. It was basically like, you could say like locked, which like when you do locking with thread, that that means like you're ensuring that only a particular thread can run at one time, and it makes sure that whatever that thread is doing is completed before the lock is released, and that means before the other threads can continue their operations. And that would like be for the purpose of making sure a particular data set was transferred as one piece and not in blocks, which might corrupt the data or cause unwanted bugs or whatever. So yeah, I think, well, we'll just keep going just to look a little bit more. Same thing here, we're iterating through a meld and we're appending each bar. And even if the packet sends before this iteration is complete, so that part of the packet, part of the list is sent with one packet, and then part of the list is sent with a second packet, it would still work because there we're gonna have a timestamp associated with the clickable card list itself. So we're not gonna be looking at the timestamp of all the cards, but we will be looking at the timestamp of the clickable card list itself, so that whenever we go to transfer that list at this point in time, right here, when this is run, or rather, anytime the clickable card list is modified or appended to, or popped from, or cleared, whatever, the clickable card list timestamp will be updated, and this timestamp would precede this timestamp because, well, it happened earlier in time. So that would ensure our data transfer integrity without having to check timestamp on an individual card basis. Same thing here, same thing here, same thing here, same thing here. Yeah, so all this. See, I put lock right here. This was where we were having a bug. I think this is actually the bug that we were having a crash issue with, and it was saying that these cards were not in the hand. And I actually have to figure that bug out. That might have something to do with copy and the objects being like copied, therefore not equivalent. Therefore, when it tries to find it, it's like not there because it's indexing a different. It's looking for a different object than what we think it's looking for. Or it could be a data transfer bug. So either way, well, if it's a data transfer bug, I think this system that we're adding, well, that already might be in place actually. I think we already might be. Well, no, we use timestamping now to, like I said, for the receiving side to ensure that we should apply the data, but not that we have organized the data and are applying it properly. So I'm just going to continue to go through these. Yeah, so I think we're good here. I'm more and more confident as I'm scrolling through, and well, so this means that for this group, these two card groups at least, we should be safe by referencing the card group that the cards are in, the timestamp for the card group that the cards are in, as opposed to looking at the timestamp for every single card. And if that applies to these card groups, that would lead me to say that also this would be true for all card groups. And I could be wrong, but I'm gonna go through and do the same sort of brainstorming review that I just did with these two, because if we can determine that we can indeed handle the timestamp checking and organization through the card group instead of the individual cards, that would mean less refactoring of existing code in this function, and it would also mean less instances, like less places that odd behavior could occur. I guess that's a good way to put it. That medicine's got me feeling like that weird tired but not tired, kind of angsty feeling. It's actually working pretty good though. I don't feel so bad anymore. At least now that I'm sitting still. Okay, so we're gonna put this in the notes real quick. And I will put this here. And we'll say, after reviewing skeleton clickable card list, dirt, check, logic, concern, say timestamp for data transfer logic. Concluded that it may be possible to, or that it may be best to handle time stamp in terms of card groups instead of individual groups. In the case that the card modification entailed or involved card group transfer and not merely card adder modifications, such as for artists. Only go off card group timestamp for receive their check instead of checking each card's timestamp. And actually, I don't even necessarily think we would have to have we'll put this principle may apply to all card groups and not merely these. Need to logic or other groups to determine the yeah, so So let's go back up here to skeleton player data dict, which handles all of the players card groups such as the hand, the priesthood play cards, the play cards, the melons, etc. And we can make a determination as to whether or not the same principle would apply. So, for instance, let's go back to progression, and we're gonna look for dot hand, and let's look at all of the, or not all of them, because there's 116 of them, but let's see if this principle would apply. Because remember, these would be ordered by the fact that they are ordered via the iteration that is, you know, like when they're being iterated through. Well, in this case, it's, well, yeah, so here's our iteration. No, I'm sorry, that doesn't apply to this. This is actually just a singular card. So, like, obviously, this would be fine because we're only dealing with one card. We wouldn't be concerned about checking the individual timestamp versus the modification of the hand timestamp, because they would be synonymous since there's only one card being modified. So in this case, when there's just one card being modified, if we were to look at the timestamp of the hand being changed, it would work just as well as if we were to look at the modification of the actual card. And yeah, so that's fine. Same thing here, but I'm looking more for when we're dealing with more than one card. Now, whenever we're popping from a card group, let's think about that. Because we have logic implemented for whenever we pop from a card group, so that whenever we pop from this hand on the server side, it will actually tell the receiving side, and it will be transferred. You know, it'll say, hey, we're going to put a P string associated with this card in this card group, and that means we're popping this card from that card group. So the question I have is concerning the timestamp. Yeah, so this would work fine, because whenever we modified the hand, if we updated the hand timestamp, it would be, you know, associated with this point in time. And then if we also were to transfer this data in the same packet, it would ensure that this data was applied first. And likewise, since the pop happens first to the hand, this would have an earlier timestamp than when the same card ends up getting appended to the master deck. But I do have a concern, and my concern is actually pertains to this time.sleep right here. Oh, you see this? This is I forgot I had this line here. I'm gonna add this to things to do real quick. So, we're gonna add it to non-pressing issues and expand it. Oops. Expand it. This will be called Return Draw Card Sleep. C line number 210. I think we can get rid of it because it was supposed to be a small mimicry of the new DTM delay data application delay system. Okay, so back to what I was working on. I was concerned. I was thinking about this. I noticed that sometimes, like let's say we pop from the hand, and then we append to the deck, and since it's only this one card, this is gonna happen so fast that I think it's actually possible and has been demonstrated in testing that I've done that according to time.time, these two events would have the same timestamp. Since time.time, let's see, go to open up test reminders, and let's import time. And then we're gonna say now equals time, and then we'll say now is time.time ns, and let's print now and then now too. Actually, I want two separate lines, so we'll do print now and then print now too, and then we're gonna do cd to testing and then run test reminders. And as you can see, okay, so time.ns actually checks 2 decimal places further than um, the they're two. This one has NS has 2 decimal places further in. It detects to a more precise degree. But I want to see, like, let's do now, and then we'll say let's add in a little bit of an operation. So we'll say L equals 1, and then we'll do L dot append 2, and then we'll take now, and then we'll say L dot pop at the 0 index, and then we'll get now too. So now we're gonna see how is, oh, see, it rounds up because, let's see, we stop at 171156340, 171156340. So this is everything that would be after the decimal point. But this is supposed to be time 2, which means when we're using time versus time 2, I mean now versus now 2, you can see that now 1, or the first now, is showing a lesser value. It's 4367. I mean, the first earlier event is showing a later time, which is incorrect, compared to now 2. And just to verify that it's not some sort of like rerunning of the actual function, I'm positive that's not how it works. But just to be extra clear, we'll do it again. And let's, alright, so the first printout will highlight for the second printout all the digits that come after the decimal. And you can see this one is 5383, this one is 5381. So how does this later value, later timestamp, have a lesser value? Because it's always increasing, you know what I mean? And we can verify this by commenting this out, and then we'll say print time dot time ns, and then we'll time dot sleep for 1 second, and then we'll print it again. And as you'll see, yeah, there's going to be a difference, a 1 second difference. So this one is 504. So at what point, well, we'll just do time for this one so we can see it goes by the second. Time uses a decimal point at the second. Oh wait, no, sleep Wait, sleep is in terms of seconds or milliseconds? That's what I forgot. Let's see. It is 1 second. It does go. Yeah, sleep for 3 seconds. Okay, yeah, sorry, I was looking at the wrong spot. So as you can see right here, there's 5-3, and then right here, there's 5-4. It's because we slept for a second. So the time goes up. The time value increases as it goes further in time. So there's no way that we should ever see there's no way that we should ever see the first printout having a lesser value, or a greater value rather, than the second. The second value should always be greater because it's later. If it's later, it is greater. But as you can see right here, when we compare time.time to time.time ns, which is for nanoseconds, it happens at the same second, but then it's 585.327, which is higher, which you would think is later, than 585.326. So we have 6 for the second instead of 7. So they're like opposite. The second one is showing as earlier in time compared to the first, and that is because, see right here, this 800, that means it's rounding up. So time.time rounds up. It's rounding this. It's probably it happened at 6,700, and this one happens at 6,800. But because it's greater than 5, this 8 right here, it's greater than 5. It's rounding this up to a 7, as opposed to the 6 that it should be. And if we change this to just time, look at it again, you'll see that these two numbers are exactly the same. And as a matter of fact, if we go back and we leave them with their variable name as now and now2, but both of them being time.time, not nanoseconds, say if now is equal to now2, print. So if these two times are considered to be exactly the same, it'll print true. And as you can see, it's true. But we know they didn't happen at exactly the same point in time. We had an entire operation happen, you see what I'm saying? So this actually does happen. And as minuscule of a thing that this seems to be, it's like, dude, you're looking at the 10th, 100th, 1000th, 10,000th, 100,000th, million, 10 millionth of a second. You're looking at the 10 millionth of a second. You would never have a bug that would be associated with 10 millionth of a second. Actually, in computing with data transfer, you actually do. That's actually a thing. Yes, you have to look at the 10 millionth of a second. Yep, it's true. This is a bug. if I were not to change my project code to use time ns instead of time, we would indeed, when we sorted the timestamp on the receiving end for the various data that came in with the packet, we would say that these two things were concurrent with one another, meaning that they happened at the same exact time. Of course, is impossible. No two things happen at exactly the same time. So now if we change this to ns and this one to ns, let's do the same thing. Damn, they still are considered to be at the same point in time. Wow. No way, huh? Pop happens that fast? Is that correct, though? There's no way, dude. Is it true every time? It is. It's true every single time. No. No, see, that time it wasn't true. So, in this one, there was a difference. 29 100 and this was 34. So out of 1 2 3 4 5 6 7 8 iteration, out of 8 iterations, here's the one that wasn't true. Hold on, 1. Here it is. 2, 3, 4, 5. Okay, I'm sorry. Out of 5 iterations, out of 5 of the iterations, one of them said that it was not concurrent, even using NS. Damn. Every time I run this, it says that they happen at the same time. But I just don't see how that could be possible. God, so this means I have to be even more accurate than NS? That's insane, dude. How is that even possible, though? That can't be right. Let's do 2 operations. Let's do it twice. Just to make sure it's not like something wrong with my actual code. Okay, I think I see. I see. What we need is we need the timestamp to happen first. We need the timestamp, but that would mean the same thing for this one, so we'd have the same problem again. This is crazy. I can't believe this. There's no way. Like, I actually don't believe this code. I don't think this can be right. Is it that fast, actually? Let's see how many appends we would have to have for it to not be concurrent. Let's go ahead. We'll have 2. Okay, out of 10, 10 out of 10. Now let's do it again. Damn. With 3 out of 10 again. Shit. I'm starting to think there's a problem with my code here because I just don't believe. There's no way. There's no way that this could happen. It could do all these operations. If we take the time here and then we append all this and then we get the now 2 and then we run pop, how could they be the same? So does this mean we're gonna have to add a sleep? Look at all these appends. This is like 20 appends. Yeah, there's got to be something wrong. There's no way that could be happening at the same. Okay, yeah, something's wrong. Because there's no way those could be the... Yeah. That's not possible. Something's wrong with this. Because this is like 50 iterations. There's just no way that this could happen within like a 10 millionth of a second. It's not possible. There's got to be something wrong with the code I'm using. Oh no, actually, it's not, dude. Look. We did 3, and 2 out of the 3 were concurrent. No way, huh? It's that fast? Yep, so there was like 5 or 6, and two of the 6 were deemed non-concurrent. Yeah, so now we finally... Wow, I had no idea that append and pop were this fast. So, guys, this is actually a big deal. I know it seems very like OCD or what are you doing with your life? Doing testing. But yeah, this is actually a legit bug because if we have them deemed as concurrent with how many, you know? Look, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 120, 130, 100, like 200. No way, bro. I am sorry, but it's hard for me to believe. But the numbers don't lie, dude. Look, the numbers don't lie. And there's hold on, dude. I have to make sure I'm using this right, because now I'm just like, am I using this? Am I confused about how time.time_ns works? I don't think I am. I really don't. Even with 100, possibly 200 appends between the first timestamp and the second timestamp, while using time.time_ns, 2 out of 3 times at that amount of append, we are still showing concurrency between the two events. So I want to look at this really quick and make sure that I'm actually understanding this properly. Similar to time, but returns time is an integer number of nanoseconds since the epoch. Use thread time ns to avoid precision loss caused by the float type? What does that mean? What does that mean? Damn, bro, I just honestly underestimated how fast computers are. Computers are so insanely fast. Similar to time, but nanoseconds. Why does it say use thread time ns to avoid precision loss caused by float type? Return the value in fractional seconds? What does that mean? What is a fractional second? What is a fractional second? Okay, like... of the sum of the system and user CPU time of the current. Okay, well, hold up now. This actually, this, guys, actually makes me think, well, if there is, if even using nanoseconds, we are determining concurrency, this leads me to say that, well, maybe instead of a timestamp, we should use an incremented counter, which would increase by 1 every time we, like, so instead of using a timestamp, we would just use an incrementing integer. So there would never be a determination of concurrency, because, you see what I'm saying? And there's no way that the value there's no way that the value would ever be deemed concurrent with its predecessor, because every time it is touched, it is incremented by 1. And let me just look for a second before we do that, because here's the other option. The other option would be that we would implement a nanosecond, not a nanosecond. We would implement a very small, well, yeah, we would implement like a nanosecond sleep at each operation. And you know, as far as the counter thing, I'm thinking, well, you know what? That's actually a lot easier, because you're dealing with an integer that's never prone to mistakes. It will never be deemed as concurrent. It's less digits to store. Yeah, and it doesn't require the execution of a function like time.time or time.timeNS, which is more performant. The only thing that we would be accessing is a simple like client attribute that would be called, like, we call it action counter, and instead of using the timestamp, we would just assign it to the action counter, and then we would increment it by 1, and then assign it to the action counter, or vice versa. We could assign it to the action counter and then increment it by 1. It doesn't really matter the order of that. Yeah. So I kind of want to share this with my peers that might be considering this, like on Stack Overflow, because this is shocking to me to see that actions are that fast. It's kind of astonishing. Anyway, I don't know if I'll do that. Maybe I will, maybe I won't. But I'm gonna take a little break. I'm gonna go take a little walk, drink some water and stuff. Okay, we're back. Me, myself, and I. We're all three of us are back. Now let's look at say Python accuracy of time.time in S. See, time centerpiece by time.time often end up being equal because of the 15 millisecond resolution. Well, this is 4 years ago. Yep, and this is exactly what I was talking about. Yep. Yep. This exactly. Yep. Same thing. To the conversion pi time as seconds double. This means time is going to be compared by converting time. Yeah, so basically added time because if you care about nanoseconds, float has a precision of around 238 nanoseconds. In float don't get the same result. Next after to get the next float towards. Handling floating point numbers are hard. Why don't use only integers? Okay, so what was the what was the final result? What is this? What's the final result? Anyway, okay, so yeah, it looks like that is a bug that is documented. Well, it's not necessarily a bug. It's it's Let's ask ChatGPT. Actually, let's ask Gemini. Um, Gemini, what is the most accurate method of time? Okay, let me get my. Why you still listening to me? Oh, Gemini, why you still listen? Okay. What is the most accurate form of time recording using Python? There's no signal. What's that? Okay. Perf counter. High resolution timer. Measures time in processor cycles. Offering more precise elapsed time measurements. Short durations, however, do not account for all factors affecting a task's execution time. Point 6F. What does F mean in time? What does F mean in time measurement?
According to National Institute of Standards and Technology,
Frequency,
conversely, the period is the reciprocal of the frequency, 2 equals 1 f, because the period is a time interval expressed in seconds.
Okay.
It is easy to see the close relationship between time interval and frequency. The standard unit for frequency is the hertz.
Okay, so
Time
let's
is the number of
let's see.
cycles per second.
So this shows elapsed time. They did a start time using time.perf counter, then an end time immediately after, with literally no no task in between. And oh, I wonder if. Well, no, it wouldn't matter. Even, yeah, if because I was thinking maybe the bug was only caused because I wasn't like subtracting one time from the other, but like I'm pretty sure that's not the case because it doesn't matter. The numbers are equal up to every single decimal point all the way through, so there's actually no difference. So yeah. Anyway, current elapsed time. Elapsed time is 0.6 f. So I don't exactly understand how that works. Let's look at this. Python perf counter. Perf counter. Now, what is process time? Return the value of the sum of the system and user CPU time of the current process. Okay, that's like for threading, like multi-processing. The perf counter. So perf counter is a float. Return the value of a performance counter, i.e. a clock with the highest available resolution to measure a short duration. It does include time elapsed during sleep and is system-wide. The reference point of the return value is undefined, so the only difference between the results of two calls only the difference between the results of two calls is valid. Use perf counter ns to avoid the precision loss caused by the float type. Okay, so I'm gonna put this right here. Perf counter. And then we'll put So let's use perf counter, and dang, I have to use the bathroom. You know how the coffee is, boys. The coffee goes right through you. Let's see. Return the value in fraction seconds of a performance counter, i.e. a clock with the highest available resolution. So using context, and then we have context managers. You can create custom context managers to track time with improved accuracy. This approach allows you to handle context switching and potential interruptions more effectively. Just the most accurate approach is you can tell the context manager to capture specific aspects of task execution. So this is like creating your own time function. This is like I've done this with similar things for like sorting and stuff. Yeah, but actually I have to really go use the bathroom. I'm sorry again. Damn it. Okay, I'm back. Okay, so let's just test perf counter. I find lots of times just testing something real quick is the fastest way to figure out which one's best. So let's do time.perf counter. Counter. Let's print now. And then print now too. Cool. So as you can see, this one is much more accurate. This one is 369 and then this one is 378. So and there's no actions between this. Now if we were to add some actions, let's say l.append 0 and then l.pop 0. Let's see what the so now the difference is even greater. Before it was only increased by 9 and then this was increased by by 9 and this was an increase by like 24. Okay, so if we did use time, we would want to use perf counter. So as you can see, time shows the same, so they would be considered concurrent, equal to one another. Same thing with nanoseconds, but then with perf counter, you get a much more accurate measurement. And then action counter would just be have action counter as 0, and then when we did l.append, we would simply say action counter plus equals 1. So that's our 4 different ways that we could do this, and let's say time. Not very accurate at all unless a clear, solid second has passed. And then also gets rounded up, which means against earlier ones with your errantly. And then time ns accurate but not for very small units of time, microseconds, nanoseconds, etc. Since during testing, in range of 100. Yeah, see, as you can see, yeah, these values are still the same, even though there was, took the time before we ran 100 times. Even if we were to take it after the pop, we still get the same values, and which is, you know, terrible. And then perf, we'll say extremely accurate, even in terms of nanoseconds, even more precise. Test with only 1x append happening between comparison B test values, then two values different by 0.0000056. Extremely extremely accurate measurement. So perf counter is the way to go. And action counter is an alternative method. Comparing order of events, which is, I believe, fail proof and even more performant than time.perf counter, since it uses a simple var and one increment per usage. Very low overhead. And we could like do a time it test, but I'm not gonna do all that. We spent enough time on it. I think that it's safe to say, if we want to use time stamping, we need to use perf counter, and if we're I should put that in notes. Reminder that time is terrible. Time is not that great either. Time.perf is very accurate, and using an incremented is even more accurate with less overhead tested this during a DTM modification. Love that song. Right when I was hovering over time, that was when he said it just takes some time. That's strange. Okay, so now's the question of now that we did this testing, which took just forever, and that's just how it is. If you want to do it right, it always takes longer than what you think it's gonna take. And this isn't just like framing a shit. You can't just have it kinda right. You know what I mean? You gotta have it perfect. Coding requires you to have it perfect. You can't have it almost perfect. It's gotta be perfect. Otherwise, you're just gonna have to redo it to fix it. So why would you not just do it right the first time? Just causes you more work, honestly. And I just learned a lot now. Now I know, time.ns is, you don't use it. You use perf counter for like these very small micro second comparisons. Events are nearly concurrent down to the smallest degree. Counter or Matter of fact, for perf counter, I'm just gonna completely, like, I'm not even gonna have an action between them. I want to see if perf counter is that precise. I'm pretty sure it is. So we just have literally no difference. I mean, no, yeah, and they're still different to the degree of 12. Okay. Even though there's literally, nothing happened, but there's no difference. Yep. Yeah, so perf counter is insanely accurate. Okay. God, I'm getting a headache. It's kind of bad. Sickness is getting to me. Okay, so we can CD back to main. Okay, there we go. So where we left off before we got sidetracked was we were questioning whether or not we would be able to use whether or not we would be able to use this system that where we don't compare, we don't look at the individual cards, we look at the associated card group. And I was going through progression looking at whenever the hand was handled. And that was when I saw this line, and I was questioning whether or not the timestamp for this hand pop would be considered concurrent with the subsequent deck append relative to time dot using time dot time or time dot time ns. And we did an extensive test and discovered that indeed these two events would almost certainly be considered concurrent using dot time and dot time ns. But that perf counter or even an action counter would be sufficient. Now we have to answer the question of which then do we want to use. Do we want to use a perf counter, or do we want to use a action counter? So that's where I'm gonna focus on right now. So let's first propose if we were to use the perf counter. So if we were to use the perf counter, we would get the current perf time whenever the hand was modified, and then we would get the subsequent perf time whenever the deck was modified. Those two values would be different. Pretty much in every single instance I've compared the two values even with no actions between them, and they still had a significant difference. So it would be safe, it would be completely safe to use it. And now, so I don't think there's really anything else to say about that other than it would work. It's fine. It would be fine to use that, and it would also be it would not require any change to our current code for the most part. We would just replace time.time or time.time ns with time.perf counter, which would be very easy to implement for the pre-existing timestamps. And yeah, so the question then is, well, for performance like overhead, how does time.time how does it compare to time.time and time.time ns? I didn't do testing on that to see which one was more performant. I don't think there would be much difference between them. Maybe there is, but not enough for it to matter for us, for our usage, I don't think. Well, especially considering when we were testing it, like, yeah, anyway. So I'm not really concerned about that. And then, so that raises the question of, well, why would we not use an attribute of the client class perhaps as an action counter, which would be even more simple and more direct and even more fail-proof, meaning that every time we modified a card group or whatever, any data point throughout the game, we would end up in comparing the thought I heard something anyway. So we would be comparing the okay, there's gotta be a rat. Rat. Oh, it's the wind. Duh, it's the wind blowing the door. I'm tripping. Anyway, um, so if we used an action counter, every time we modified the hand or the deck, we would, instead of assigning the timestamp to be a time, we would simply increment that counter by 1 and then set that timestamp. Instead of calling it a timestamp, we would just call it an action counter or whatever. And that would mean uh, yeah, so that would mean that we would be able to increment by 1 every time we handled something, and then it would just get transferred as a timestamp would, and whenever we received it on the receiving end, that timestamp value would well, it wouldn't be a timestamp, it would be a counter. We would just look at the counter list instead of the timestamp list and order the application of the data based on the each associated card group's action counter. So like honestly, I think that it would. Okay, so here's the question with the action counter. If we were to use that, which I think is would probably be the most performant, it would probably be like the fastest and the cleanest and the most fail proof. Since it's not a like we're not multi-threading alterations, like, because I think that if we were to use a counter and modify it on multiple threads concurrently, that would cause bugs, and I think I read up about that. There's a term for it, I can't remember, but yeah, if you modify a value on 2 threads like that, like a counter and incrementing it, like before one thread could return the value, you would, before one thread could return the value, the other thread may grab it, and then you may end up having 2 values with the same action counter value errantly. So in that instance, uh, with multi-threaded modifications, I'm pretty sure we would want to use perf counter to avoid that. And I just want to verify that that is a thing. I'm pretty sure that is a thing. So let me ask Gemini. In Python programming, when you are multi-threading, if you grab one attribute and increment it on both threads before the first thread can return the value, will you get errant results? So Gemini is not very good at understanding me, I noticed. Like, I don't know if it's my mic. In Python, when you're multi-threading, if you grab one attribute and increment it on one thread, and increment it on one thread, on both threads before the first thread can return process the increment, will you get errant results? Meaning that the yeah, I think that's a good enough way to word it. I'm not positive, but Python, when you're multi-threading, you grab one attribute and increment it on both threads before the first thread can finish processing. What's up? Dude, I was like so sick I had to call in again today. But I didn't have a sick day, so I'll probably get wrote up. I got like an excuse through the doctor, but I don't know. They might, you can like appeal it, and they might remove it if I have an excuse. Your cat's outside. I let her outside like an hour ago. Him. He kept meowing on the counter. So let's see what they say. Python, when you're multi-threading, if you grab one attribute and increment it in both threads before the first second to first thread, will you get error results? Yes, you get error results by the multi-threading if you're modifying some measure and multiple threads without proper synchronization. Situation is a classic example. Okay, yeah, so it's called a race condition. Oh, your dad made some like casserole or something. Oh wow, that sounds really good. I went to get the stuff from Walmart. Kind of didn't feel like cooking though because it just felt like shit. I just feel like sitting still. I took so much medicine. So you might want to sanitize the handles or something. Because I think it might be contagious. Thought it was just sinuses, but I think it's like a cold, because now my snot has like more color to it. It's not just clear anymore. Yeah. Yeah, unfortunately. Hopefully I'll be able to go in for tomorrow. I got an excuse for today and tomorrow. I really don't want to miss a day because I can't afford to miss again. Not getting paid. It sucks. Anyway, so this situation is a classic example of what we call a race condition. So that was the term I was looking for. I did study this before. And so here's what happens in our scenario. Shout out to Gemini for giving the perfect answer again. Thread 1 reads the current value of the attribute. Let's say it's 0. Thread 1 performs calculations to increment the value. Example, adds 1. Context switch. The operating system might switch execution context to thread 2 before thread 1 finishes the increment. Thread 2 reads the same attribute value, still 0 because thread 1 hasn't finished. And then thread 2 performs calculations to increment the value, adds 1. So thread 2 performs calculations to increment the value, adds 1. Thread 1 finishes the increment and attempts to write the new value, should be 1. Thread 2 finishes the increment, attempts to write the value, should be 1. So yeah, in this case, as you can see, they're going to both end up with 1, even though it should be 1 and then 2. So that's called a race condition, and that would be the issue with using the same using a what you call it? That would be an issue with using the action counter as like a client attribute, because it would be susceptible to this. Now, in our current application, in our specific conditions, I am not, like, I don't think that well, no, actually that's not true. We probably would have some race conditions stemming from that if we did do that. I can't think of any specific instance off the top of my head, but it's just not safe. Like it's safer to use a it's safer to use a time.perf counter, and that will avoid the race condition issue by, you know, like it's never trying to grab the same object from both threads. It's always basically, like you could say, creating a new object that reflects the current time to a very accurate degree. So after the analysis here, we can, I think, safely say that we should not use a variable, an incremented variable, despite the simplicity and lower overhead that it would offer. So we'll put concluded after analysis that action counter adder may probably would be susceptible to race conditions as while perf counter would not have this issue. Therefore, time.perf counter is most likely the best solution. 321 to 348. We analyzed the usefulness, security, logic of using adder action counter versus time dot perf counter. Concluded that we can just copy this from here. So I just got it right. Include that action. Therefore, is the best solution and is the option we are going to now we're going to okay, what do I do now? Don't feel like booty. I'm gonna go like 10 more minutes, then I'm gonna get some coffee. Drink some water or something. What's up, Mr. Brian? I don't know. I think he hopped in his car. He came in and he brought in that casserole or whatever, and then he stepped out, and I heard his car crank up.
Tell him this is his bag for his meter.
Okay, I'll let him know.
You got to put his meter bag in so he don't get busted up.
Gotcha. I'll let him know.
Alright. You still sick?
Yeah, well, I just got sick yesterday. I called in and used a sick day. Today I had to call in again. I got an excuse and everything, but yeah, it's like a sinus cold. It's pretty bad. I done took a whole bunch of Dayquil and all that, but you know, headache and just yeah. I used it last night actually to wash that bedding, and yeah, it worked real good. I didn't check that honestly, but I'll mention to him to check that to see if it leaked at all. Uh-huh. Oh wow. Yeah, I told him to hang on to that old one, and I'll take it when I go back to the house and at least keep it there for instead of just putting it by the road or whatever. Okay, yeah, and because mine actually had went bad. We got a new one from my wife's grandmother who passed, and it had problems with the buttons. It was them all electric buttons, you know, and it wasn't but maybe a 6 months old. So lots of people have this problem. The buttons quit working, so I had to drill a hole, and it's like a contact, electrical contact. You got to touch it with a screwdriver. But I said, you know, if that went bad after 6 months, the whole washer might go bad. So it might be a good idea for me to try to get that one and keep it as a backup just in case. I'll tell him to check the the hoses and everything on the back. Well, she actually she she actually let me turn this because it's listening to me.
severity and duration of cold improvement.
heard it. I was gonna come wake you up, but it was like really early, so I figured like you didn't. Figured you just said it earlier just because. It was like 3 or something. Damn. Gotta be careful though, speeding on the interstate. That ticket goes on your record. It'll fuck up your insurance. That's what I do. I try not to ever go over 60. If you go like 55, you'll get like 3 more miles per gallon than if you go 60. And then if you go 60, you get like 3 more miles per gallon than if you were to go 65. And if you go like 60, between 60 and 70, it's probably like 6 or 7 miles, well maybe not that much, probably like 4 or 5 miles per gallon. It's a big difference though. That too, yeah, I didn't even think about that. Oh yeah, that's what it is. It's not the efficiency of the engine, it's the air resistance. I didn't even think about that. That makes sense. You know, I never realized that. Yep, I did. That was crazy. Okay. Alright, so I gotta do some more. I'm gonna go till 5. So we'll do another 42 minutes. So we decided that we're gonna use perf counter because it's really precise, and we can't use a action counter because it's susceptible to multi-threading race conditions. So therefore we can go ahead and continue with our analysis of whether or not we can use the card group timestamping instead of the individualized timestamping. So in this case, there wouldn't be an issue. We would be popping from the hand and then appending to the deck, and then so this would have a particular timestamp. Now, okay, what about this though? What about whenever you have multiple timestamp? What about if you have multiple hand modifications? Like, let's say we append 2 cards to the hand, then append a card to the discard pile, and then another card to the hand, and all that got sent in one packet. If that was the case, then it would determine that all of the hand operations should happen first, even though the discard pile would technically be you know, in between two, it would be the 2 cards from the hand and then the discard pile and then the 3rd card of the hand. So that means we would, in that case, have to actually use an individualized approach. But the question then is, does that happen? Does that actually happen? Or is that a non-occurrence? Is that something that occurs, or is that something that doesn't occur? If it's something that occurs, we have to go individual. If it's something that doesn't actually occur, See, like in this instance right here, we're iterating through 11 cards, we're making 11 iterations, and throughout these 11 iterations, we're going to be popping from the deck and appending to the hand. Now, this means that every time we update the deck and the hand, the timestamps associated with each one are going to update. Now, this means that technically, if all this was sent in one packet, whichever one happened last, or rather, like, let me figure out how to phrase this. Whenever we sent this packet, it would do all of the deck modifications and then all of the hand modifications. It wouldn't do it in the proper order. See what I'm saying? Or would it? Because of the order of the operation itself through the iteration. Like, meaning that this deck would have a particular, this action would have a particular timestamp, but it would only be associated with the deck, not with the actual card. And if we ran dirt check and applied this, all of this data that came along with that packet, we would I'm just trying to think, like, is that what would happen? Would it I don't think it would. Hold on. This is something I have to think through, like, step by step. So each time we popped from the deck, it would give us a new timestamp using perf counter, which is extremely precise. And that's good. That means each pop would be differentiated. But does that mean yeah, actually I think that would be fine. I'm trying to think about this clearly. It's kind of hard to just imagine it, but it's a lot faster to imagine it than it is to try to, like, test it or type it out. So we would have 11 deck timestamps. So I guess the main concern would be that each action that's associated with an individualized timestamp on the deck would that on the receiving end result in only modifying that particular action. Like, it wouldn't have other actions that happened alongside it that we didn't want to happen. And yeah, as long as we made the correct modifications to dirt check, I'm pretty sure we would be able to do it like that. Because my concern was, I think my concern was that whenever we modified the deck, we're going to be updating the deck timestamp. And then when we modify the deck times, let's say we're in between packet sends right now. So a packet's just been sent. Then we pop a card from the deck. That updates the deck timestamp to that point in time. Then we still don't send the packet. We would then append to the hand. That would make the hand timestamp value be that point in time. And then we still haven't finished this packet send yet. We're still going to put more data in it. We would then pop from the deck again. Now this would update the deck timestamp to be even more recent. So that first deck pop is no longer technically accounted for. Like, it has pretty much been overwritten and is gone. So that whenever we sent the data, we would have no way to reference that timestamp. So what we have to do, I think, is we can still use the timestamping as in terms of the card group, but every time we modified any card group, instead of merely updating the deck modification timestamp, we would actually, like, we could modify it and use that value, because they would never, I don't think we have to worry about race condition. I don't think we would have to worry about a race condition concerning that timestamp. Like, meaning, let's say we might have a race condition. Let's say we have the deck timestamp. We pop from the deck, we update the deck timestamp, and then at the same time, on a different thread, we're receiving, well, we actually don't update the deck timestamp when we receive through dir check. So that logic would have to be added as well to make sure that, like, when we're receiving data and not altering it from the source, that we don't update the timestamp in that instance. We already have logic for that implemented in various places, but we don't have it completely implemented. So that would definitely be a consideration. So I'm going to put that here as a requirement. So requirement number 4, and this is going to say, have to ensure that we will not be updating the timestamp values when receiving, updating card groups, so as to avoid multi-threaded race conditions and other errant data assignments. Quite sure this is already implemented for certain timestamp related logic. Enter check and elsewhere. Can't remember exactly where, but Like, I'm pretty sure we do have that implemented. So yeah, so this proposition that we're speaking of, that would involve the risk of a race condition, wherein if we had the deck timestamp updated on the main thread whenever we popped from the deck, and then or almost concurrently on one of the other two threads, we would receive deck data that would update that timestamp before the timestamp could be returned from this pop. Then our timestamp would not be equal to the time that this was popped. It would instead be equal to the time that we modified it after receiving data. So yeah, that would just be avoided by implementing this logic that we're talking about here, which is I think pretty easy to take care of. I think it wouldn't be, we already have some logic like that implemented. So what was my other concern? Oh yeah, so my other concern, right, was about how the timestamp being updated, like having a singular timestamp attribute for the deck, but the fact that it would be updated frequently. Like in this case, it would be updated 11 times in a very short amount of time, which means all 11 of these alterations would result in 11 updates to the deck timestamp attribute, and how that relates to ensuring that the first 10 timestamp alterations are included as part of our logging, like part of our data ordering, to make sure that we know this first pop that involved this card at index 0 happened first, so that when we transferred it over the network, we would make sure that it gets applied first. So this means, and I'm like, I don't know if I actually have the logic for that implemented already. So yeah, this is actually like a new discovery, because previously we were going to, prior to the dircheck send, we were just going to check the dircheck, well, what we're going to call the client.changed, not change attribute dictionary, the timestamp list, and if anything was different, we would know that it had been changed. But I think a more proper way to do it would be to actually as soon as we change this data, meaning like as soon as we execute this pop, that the deck timestamp attribute is updated, but also all the information associated with this data alteration is stored somewhere, like in the changed attribute dictionary, which means that basically prior to sending, instead of checking the timestamp dictionary or the timestamp list to see if the timestamps have been altered, we would just like bypass that, and we would already have a list of the data modifications that have been made since the last packet stored in the changed attribute dictionary. The only thing though is, like, that's kind of complicated. At least I'm not sure how our current system is is currently coded to accommodate that alteration to the data transfer. So yeah, I think what we'll do is we're just gonna have to write this as a requirement. Again, this is another requirement that I don't think I've actually accounted for that yet. This that's something new and it's kind of a big deal. So we'll put instead of using the time, instead of pre-send dir check referencing the time list, or whatever it's called, the time list, time dict, whatever it is, to determine whether alterations have been made to a particular attribute. We should instead reference the we should instead reference the changed attribute list, which would be directly updated at the exact moment the data modification, or the modification was made to the adder. In other words, we would at the point of an append, for instance, update the associated card group timestamp attribute and
Tempora mori, tempora mundus recordas. Voilà.
let's see. We would, at the point of an append, for instance, update the associated card group timestamp attribute and also append the details of the data modification to the changed attribute list. Okay, 19 more minutes. So how exactly would that work? So this would mean we'd have to modify our steps. So let's see our actual step-by-step implementations. So create types of energy for online counted adders. Let's see. Okay. Then we create the timestamp logic, and then inside of dircheck, update the client time dict prior to sending data. Update the client time dict prior to sending the data. So this would be a modification to this. This would happen. Let's see. Okay, hold on. Actually, okay. I think honestly we would have to add this information prior to it being added to prior to dirtcheck being run. Because if we only ran it from dirtcheck, let's see, let's go to the send section. Like, yeah, we definitely would need to add it, because for instance, dirtcheck only gets run every so often, but we need to have that timestamp added immediately, and it has to be associated immediately with that data that we changed, which means like this would have to happen at a different level of code. This would have to happen at like, this would have to happen either through like calculated properties, so on and so forth, at the exact point of the data change. We would need to append the data, which this currently happens in dirtcheck. This is work. Damn. This is actually stressful because I'm realizing that this is actually a big deal and I just didn't like think about it. It's crazy how you just don't realize things until, you know, you have to. And then it's like, wait a second, Actually, I'm just gonna minimize this, and I'm gonna look at the other dirtcheck because that one doesn't have all the comments on it, so I can see exactly how it works right now. Let's go all the way down here to the next, right here. Alright, so right here we would say, let's go down to the send section, And I guess I'll comment this out. Or uncomment it out. And then we're gonna go to the send section. Alright, so here we are at the send section. And this part only gets run in dircheck. And so this is where all the logic is. Ah, so here's an idea. What if at the time of the data alteration we actually caused the dircheck to be called automatically? You see what I'm saying? You follow what I'm saying? To where we wouldn't have to move any logic. Now that's actually really smart. That, like, well, it might work, because I was thinking, oh no, this means I'm gonna have to relocate all of this logic and it's gonna be like a nightmare. Where am I gonna put it? Like, I'm gonna have to disperse it throughout all these just millions of random locations that there's no consistency or one place to look, you know what I mean? Like there currently exists with this function and the send section within the function. But if I can call dircheck, so where's my requirement right here? Let's say, yeah, so we'll put, we could make it so that upon data alteration, or rather more specifically upon a derivative of the updating of the timestamp value via timestamp being a calculated property perhaps. So we can make it so that upon data alteration, or rather more specifically upon a derivative of the updating of the timestamp value, dir check would be called for pre-send data modification recording to changed attribute list. But we can make it so that upon data alteration of the updating of the timestamp value, dir check would be called with certain parameters to designate be called with certain parameters to designate that, or rather to execute logic what logic exactly are we talking about? So we're talking about the logic which handles the insurance of the data modification being added to the associated changed adder dict. Perhaps we could modify this more broadly so that we would directly append this data alteration and the associated timestamp, etc. to the changed attribute list instead of the changed adder dict. This could be a future implement, and I don't think it would be necessary for DTN to work, but could be a future improvement. Okay, so we have to figure this out. I'll put stopped here. 1, 2, 3, 4, 5, 6. Stopped here. We have to figure this part out before we can continue. Yeah, very important. And where exactly did we okay, so let's actually go ahead and recollapse that. So we'll just undo this change. So now it's re-commented out. We can hold up. First, we're gonna minimize, collapse it, recollapse it. Now, no, that doesn't work. Why doesn't that work? Why won't it let me collapse the entire function? I'm confused. Huh. Why is this the case? Why won't it let me collapse this? Right here. What's the problem here? Wait, what? Local working changes? What does this mean? Whoa, what's going on here? What is this? So something happened here, and like it's I don't know what this is. It's not letting me collapse this entire function now. I don't know what I did. All I wanted to do was collapse the function. Okay, so whatever. If we can't, then we can't. It's... I guess I'll try to do it one more time. Yeah, so there's that blue line right here, and I'm pretty sure that's the same thing. It's not gonna let me do it. Yeah, I don't know why exactly. I think it's because I commented all this stuff out. But I'm actually just gonna leave it. Since I can't collapse it, whatever, I can't collapse it. That's just the way it is. I don't want to mess with it anymore. So we'll close out this, close out, make sure I didn't make any external changes here, which I don't think I did. Okay, now we can close this one. Now we have our thing to do, and actually I forgot to go to where we, not progression, well, no, yeah, not progression, it's client. So we're gonna go all the way up here. Receive false state update. No. So this is gone. This is a copy of their check which we will work on to restructure going using DTM. Okay. Good. 1, 2, 3, 4, 5, 6. Stop. Here. Need to implement system for how dirt check presend dirt check logic will be called via timestamp as calc property upon to ensure addition of every data point change to be added attribute, list all associated changed pattern predict before we can continue working on changing this code. Okay. So we're gonna copy that and we'll put this on things to do. Okay. Oh, that's some heavy stuff today. That was heavy. Um, so then we need to add in code for presender check logic, and I can just, I think, copy this. Yeah. Okay, so now so first we're going to stage our changes, so we're going to go to the correct directory, git branch to make sure we're on the right branch. We are on secondary, then we're going to git add all of our changes. We can ignore those warnings. So git commit and cool. So we did 5 files changed, 155 insertions, 9 deletions. And then we're gonna say git push Canasta. Oops. Okay, so it did it. We meant to put git push Canasta secondary. That scared me. Already up to date. Whew. Now that's done. Okay, so now we can actually go ahead and make the copy, the local copy. So we're gonna go to programming projects, Canasta. We're gonna copy this. Now we're gonna go back to backup. We're gonna delete the current backup. Now Google Drive is letting us know that we deleted it and it's going to be deleted off of Google Drive. But we now implement our new copy. We're going to check it and make sure that the devlog has the most current, meaning that it is the proper version, and indeed it is 327. That is the date today. So now we can go back to here and we're going to rename this to the proper date, so we know that was the